Compositions in the paper 19 MA 212 Algebra and Number Theory. So in this lecture, we are going to discuss about least common multiple. That is nothing but LCD. Definition. So the least common multiple of two positive integers A and B is the least positive integer divisible by both A and B. In their GCD, we are taking the maximum, highest divisor is the GCD. Here, the least positive integer divisible by both A and B is the LCM. So it is denoted by closed interval A comma B. So simply they are notating closed interval A comma B means that is representing least common divisor or LCM of ABB. Short form of least common divisor common multiple is LCM. Let us have a note. A is equal to P1 power alpha 1, P2 power alpha 2, etc. are the canonical decomposition of A comma B. Then that's very important note. LCM of A comma B is equal to first prime factor power maximum of alpha 1 comma alpha 2 dot second prime factor power maximum of alpha 2 comma beta 2 etc. pk power maximum of alpha k comma beta k. This is very important note. Based on that only we are developing the least common multiple terms. The first problem, find the LCM of 1050 and 2574. So we have to find out LCM of the given two numbers. First I am going to divide by using the prime factors. 50 each separately we need to find out the prime factors at first. 1050 it is divisible by 2. I will get 5 to 5. So it is divisible by 5. Again I am getting 105. This is also divisible by 5. I will get 21. This is divisible by the prime number 3. So at finally I will get the prime number 7. Like away the second term also 2574. Last number is 4. It is divisible by 2. I will get 1287. This is divisible by 3 because the last two digit addition value is 15. 15 is divisible by 3, no? So obviously this is divisible by 3. So this is one way of finding the divisibility in short form. Yeah, here 429. So this is divisible by 3. Again I will get 143. So this is wrongly came here, 143. So therefore at finally I will get 13. So therefore this is the factors of each term. So first we find the canonical decomposition of the given two terms. 1050. So we will get 1050 2. Only 1 2 is there. So 2 power 1 5. 5 power 2 3 power 1 7 power 1. So 2 power 1 3 power 1 5 power 2 7 power 1. For the second case 2 power 1 3 power 2 11 power 1 13 power 1. So 13 power 1. So this is for the second number. Here 2, 3, 5, 7 is there. Here 2, 3, 11, 13 is there. For understanding purpose, I am just keeping all those terms intercollaborated for both. Here 11, 13 is there. Here there is no 11, 13. That's why I am keeping here 11 power 0 and 13 power 0. Here 5, 7 is there. But here there is no 5, 7. That's why I am keeping here 5 power 0, 7 power 0. And this is only for understanding purpose. No need to mention it here. So next, LCM of A comma B is nothing but the product of factors with maximum indices. Let us have closed interval A comma B is equal to that, which means what? LCM of the given two terms. So here I am having 2 power 1. Here also I am having 2 power 1. Look at the factors. Here 2 power 1. Here 2 power 1. So therefore 2 power 1 comma 1. Maximum of 1 comma 1 is 1. Of course 3. Come to the next factor. 3. Here 2. So 3 power 1 comma 2. Maximum of 1 comma 2. Maximum value is 2. So therefore you just keep it here. Next 5. 5 power 2 comma 0. Maximum of 2 comma 0 is 2. Next 7. 7 power 1. 7 power 0. Maximum value is 1. So therefore 7 power 1. 11 power 0 comma 1. 1 is the maximum. and 13 power 0 comma 1. 1 is the maximum. So this what I am getting the factors. After multiplying, I will get 450 comma 450 is the LCM of the given two numbers. So let us have the second problem. Find the LCM of 120 and 500. So we have the LCM of 120 and 500 below. So each I'm going to find out the factors at first individually. 120 divisible by 2. After that 60. 60 also divisible by 2. I'll get 30. 30 is divisible by 2. I'll get 15. 15 divides 3. It is divisible by 3. I'll get finally 5. This is prime number. Stop here itself. Come to the second case, 500. 500 divisible by 2 is 250. 250 divisible by 2 is 125. 125 divisible by 5 value is 25. This divides 5 value is 5. Therefore, first we find the canonical decompositions. So 120 is equal to, so 120 factors are 2 power 3, 3 power 1 and 5 power 1. 2 power 3, 3 power 1, 5 power 1. So next 500 factors are 2 power 2, 5 power 3. 2 power 2, 5 power 3. So here 3 is there, here there is no 3. That's why I'm keeping here 3 power 0. So again I'm telling this is not necessary to keep. So let us have LCM of 120 comma 500 is equal to product of factors with maximum index. So which is equal to compare the powers. 2 power maximum of 2 comma 3. 3 is the maximum. Keep it here. 3 power 1 comma 0. 1 is the maximum. So we will take 3 power 1. 5 power 1 comma 3. Here 1, here 3. So maximum is 3. So therefore this is this multiplicative value gives the LCM of the given two numbers, that is 3000. So very important results. Some of the results are there for finding the least common multiple. If A and B are positive integers, then LCM of A comma B is equal to A dot B by A comma B. GCD of A comma B. If P is a prime and P divides n factorial, then the highest power of P dividing n factorial in its canonical decomposition is so n by p plus n by p square plus n by p cube plus etc. So if it is a finite sum because n by p power n is equal to 0 when if p power m is greater than n. So denominator is greater than n. Use regression to evaluate. In GCD also we would have seen more than 2 terms, so there means we are using the regression. Here also they are given 4 terms, so therefore in this closed bracket indicates LCD. We have to find LCD of this particular one. We isolate each term from the right and find the LCM of the inner groups as below. So like 24, 28, 36, 40. So we are going to isolate this as like from right to left. So first 3, the last one. And again we are going to grouping as like inside these 3, 24, 28, 36. Now I'm finding the LCM of 24, 28 at first. 24, 28 LCM is 2 power 2.6.7. This gives 168. So after replacing that into in place of 24, 28, I will get 168, 36. Again we need to apply the LCM of this particular thing. I will get 2 into 2 dot 3 into 14 into 3. This gives 504. In place of this in the previous step, here I need to apply 504. After applying 504, 40. So this may gives 2 power 3, 5.63. So this answer is 2520. So this is the LCM of the given system of numbers. So let us have the next problem. Use regression to find this particular system LCM value. We have to find LCM of this one. We isolate each term from the right and find the LCM of the inner groups as below. we are grouping like that. So after grouping, finally I will get 15 comma 18. I'm going to find out LCM of 15 comma 18. It will give 90 is the answer. I'm going to replace this into in place of the previous step. I will get 90 comma 24. This LCM value is 360. So 360 at finally in place of 15 comma 18 comma 24, I am replacing 360. I will get 360 comma 30. So this LCM value is again 360. 30 is a factor of 360. Okay, the next thing, find the canonical decomposition of 23 factorial. So look at the previous slide. So we are having one formula for finding the canonical decomposition, right? So n by p plus n by p square plus etc. n by p cube. We are going to apply this formula for finding decomposition for 23 factorial. So the primes dividing 23 factorial or 23 factorial is factorial values start from 1 up to the current number. So this is the factorial value. We need to pick the prime numbers inside this value. So 1 is not a prime number, 2 is the only even prime number, 2, 3, 5, 7, 11, 17, 19, 23. These are all the primes inside 3 factorial, 23 factorial. So after that, we are going to find out the power value of each and every prime. The power of 2 dividing 23 factorial is substitute in this 2 into the above formula. Here n is equal to what we are given is 23, so that is n. Prime, we are taking the first prime 2, right? In place of p, I am replacing 2. So therefore, I will get 2 23 by 2 square plus 23 by 2 cube plus 23 by 4. So therefore, I will get the final answer is 19. Next, power of 3 dividing 23 factorial is 3 power 3, which is equal to, which is greater than 23. So therefore, 23 by, of course, 3 power 3 means it exceeds numerator, right? That's why I'm stopping here. Here, why I'm stopping up to 2 power 4? After 2 power 5 means that exceeds 23. So that is not possible. So denominator must always less than the numerator. Then only this formula is possible. So up to this only we can express. When I'm going to 23 by 2 power 5, the denominator exceeds numerator. So that's why I'm trimming the formula up to this. Yeah, here also when I'm move to the third step, 3 power 3 is 27, that is greater than the numerator. That's why I'm trimming up to the second step. 23 by, here prime factor is 3 plus 23 by p square. P is 3, n is 23. So this gives answer 9. Next, power of 5 dividing 23 factorial. So here also second also not possible because 25 is greater than 23. So we have only the first term 23 by 5. This is 4. Next 7. Next prime number is 7. So here also the first term alone that gives answer 3. 11 also first term alone that gives the answer 2. So the power of 13 divides dividing 23 is 23 by 13, which is equal to 1 time, because this representing, this closed bracket representing ceiling of the answer. So this may give some 1 point something, no, we may take only the ceiling of this answer for all the terms. So we will get the whole value, not decimal one. So therefore 17 gives 1 point something, no, ceiling of 1 point something is equal to 1. So the power of 19, that is also 1 point something, we will take 1 alone. So 23 by 23 is 1. So therefore the canonical form of 23 factorial is product of all those things, 2 power 19, 3 power 9 up to 7 cases. Yeah, here I will get, when I'm having the power dividing 2 dividing 23 factorial, I'm getting 19. No, so therefore I just want to keep 2 power 19. When I'm using 3, I'll get 9. So therefore dot 3 power 9. Likewise, we need to take. When I'm using the power of 5, I will get 4. So therefore 5 power 4. So next is 7 power 3, 11 power 2, 13 power 1, 17 power 1, 19 power 1, 23 power 1. Likewise, we need to take the dot product of all those things. It will give the final answer. So let us come to the end of this lecture. So this ends this unit. In this unit, we are learn about division algorithm, base B representations in this system, either binary to octal or hexadecimal or hexaoctal to binary. These things are we discussed in this one. Prime and composite numbers. Here also how to find the consecutive composite numbers and how to identify the prime numbers. These things are we are discussed in this particular one. And GCD, for finding GCD we are seeing 3 categories. Canonical decomposition, only 2 terms are there, means we are using canonical decomposition. Regression means more than 1 terms, means we are using regression. Euclidean algorithm, they itself mentioned by using Euclidean algorithm. By using this, we are writing the linear combination of the number itself. So next thing is fundamental theorem of arithmetic. The last one in this video, we are discussed about the LCM, least common multiple. So these are all the topics in our first unit. We covered all those things. Thank you everyone.